Imagine a universe where everything is exactly the same but opposite. A world where up is down, left is right, and all that we consider as matter is replaced by something else. This isn't a science fiction plot, but a fundamental concept in the realm of physics known as antimatter. Antimatter is the mirror image of the matter that makes up everything we know, from the stars in the sky to the device you're using to watch this video. It's a concept that sounds straight out of a sci-fi novel, yet it's as real as the air you breathe. For every particle of matter in the universe, there's an antiparticle, an identical twin in mass but bearing an opposite charge. So, if you've ever wondered about the existence of an alternate universe or a parallel reality, science might have an answer for you. So, in the world of physics, antimatter is the perfect evil twin to matter. To understand why antimatter exists, we need to travel back to the beginning of the universe. Picture, if you will, a time before time, a place before space, a singularity of infinite density and temperature. This is the state of the universe at the moment of the Big Bang, a cosmic explosion that marked the birth of our universe. The Big Bang didn't just birth time, space, and energy, but also the building blocks of everything we know, matter and its mysterious twin, antimatter. Just as a potter molds clay into various shapes, the Big Bang shaped energy into particles of matter and antimatter. According to the Big Bang theory, the universe should have created equal amounts of both. Now, matter is the stuff we're made of, everything we can touch, see, and feel. Antimatter, on the other hand, is like the mirror image of matter. Each particle of matter has a corresponding antiparticle, identical in mass but opposite in charge. Here's where things get interesting. When a particle and its antiparticle meet, they annihilate each other, disappearing in a burst of energy. Imagine for a moment a world where matter and antimatter exist in equal portions. The result would be a cosmic fireworks show of constant annihilation, producing nothing but energy. So, if the Big Bang produced equal amounts of matter and antimatter, we're faced with a rather existential question. Why are we here? Why didn't everything just annihilate? This question is at the heart of one of the biggest mysteries in physics. If matter and antimatter were created in equal amounts, there should be nothing left but energy. Yet, here we are, on a planet made of matter, in a universe seemingly dominated by matter. So if the Big Bang produced equal amounts of matter and antimatter, why are we here? Why didn't everything just annihilate? The survival of matter in a universe of equal matter and antimatter is one of the biggest mysteries in physics. In this vast cosmic arena, a puzzle lurks. It's a conundrum that's been bothering scientists for decades. It's called the matter-antimatter asymmetry puzzle. You see, our understanding of the universe suggests that at the time of the Big Bang, equal amounts of matter and antimatter should have been created. But if that were the case, they should have annihilated each other, leaving nothing but energy. Yet here we are, in a universe filled with matter and almost no antimatter. How did this happen? This is where a little-known concept called CP violation comes into play. CP violation is a violation of the combined conservation laws of charge conjugation symmetry, C, and parity symmetry, P. In simple terms, it's the difference in behavior between matter and antimatter, and it's a key player in our story. The standard model of particle physics predicts a tiny amount of CP violation, which could potentially explain the surplus of matter over antimatter. In a universe that was created with equal parts of matter and antimatter, it's this tiny bit of CP violation that could tip the scales in favor of matter. Let's imagine it this way. For every billion pairs of matter and antimatter particles created in the Big Bang, one extra particle of matter was produced. When all the matter and antimatter annihilated each other, that one extra particle of matter survived. And it's those surviving particles that make up the stars, planets, and even us. But here's the catch. The CP violation we've observed so far is much smaller than what's needed to account for this surplus of matter. This suggests there's more to the story, and the search for that missing piece is one of the most exciting quests in modern physics. So, the existence of antimatter is a key clue to understanding the universe's past, and possibly its future. It's a cosmic breadcrumb trail that could lead us to new, unexpected revelations about the nature of reality itself. Despite its elusive nature, antimatter has found its way into our world. Today it's not just a fascinating topic for theoretical physicists, but a practical tool that's found its place in modern technology. One of the most common uses of antimatter is in positron emission tomography, better known as PET scans. In medicine, these scans use positrons, the antimatter counterpart to electrons, to create detailed images of the body's internal structures. This allows doctors to diagnose and monitor diseases like cancer with remarkable precision. Beyond healthcare, researchers are making strides in understanding antimatter. Laboratories around the world are working tirelessly, creating antimatter particles for study. These efforts aim to uncover the secrets of this elusive substance and potentially harness its power for future technologies. So, while antimatter may seem like a concept from science fiction, it's a very real part of our universe and our daily lives. So, why does antimatter exist? We've journeyed through the creation of antimatter, born out of the fiery crucible of the Big Bang. We've wrestled with the mind-bending puzzle of matter-antimatter asymmetry, asking why our universe is dominated by matter, while antimatter is scarce. We've seen how antimatter, once a mere theoretical concept, now plays a significant role in modern technology, from medical imaging to fuel for future spacecraft. Indeed, the existence of antimatter illuminates the intricate beauty of our universe. It challenges our understanding, pushes the boundaries of our knowledge, and invites us to continually question, explore, and discover. It's a testament to the complexity and richness of the cosmos. The existence of antimatter is not just a curiosity, it's a fundamental part of our understanding of the universe. So next time you look up at the stars, remember, you're not just looking at matter, but also the shadow of antimatter.